In this video, I'll be comparing the two primary methods of doing AJAX-style page updates in your ASP.NET application. To do this, I'll use the demo applications from two previous How Do I videos. First, video number 1, How Do I Get Started with ASP.NET AJAX, which uses the update panel as the method of page update. And then secondarily, we'll compare that to the demo code from video number 5, How Do I Make a Client-Side Network Callbacks with ASP.NET AJAX. So first let's look at the update panel mechanism, and I've got the demo code loaded here in Visual Web Developer. So you see here we've just got a pretty simple user interface. We have an update panel. Inside the update panel I've got some HTML, one portion of which is this ASP.NET label control. Then I have a button. The button has a click event handler that is a null op, so it'll just cause the post back to the server, but it doesn't actually do anything itself. In fact, the label controls that are on the page are updated by logic in the page load event. What this implies is that when we're doing this sort of a post back, the entire page lifecycle executes back on the server. As we'll see, not only is that the truth, but there's some additional considerations that might not be immediately apparent to us when we're using the update panel because it's so easy to use. And that, in fact, is the benefit of the update panel. The update panel is a very clever implementation by the ASP.NET AJAX feature team to make it very easy to do AJAX-style programming without having to write lots of client-side code. But as always, that simplicity comes with a certain price. So I have a version of that application running here on my local web server, and we're going to use a tool called Fiddler to evaluate the HTTP that's being passed back and forth between the client and the server. One note about Fiddler is that Fiddler does not intercept and proxy calls to local hosts. So I'm just accessing my local IIS server using my machine name as the server name as opposed to localhost. So let's fire up Fiddler. And I'm going to refresh the page so we can see the entire page load in Fiddler. Right? So you can see we've got 4 different request portions here. Now let's go back into the page and click the button which will cause the update. Now remember what just happened. We did a full page post back because it's a button click event, and similar to any sort of event that would cause the update panel to be updated. Then back on the server, because we see that our date time got updated in label number 2, we know that in addition to the post back to the server, the full page lifecycle executed because it's not the button click event that causes these updates, but it's actually the page load event. If we head down here into Fiddler, we can see we have this additional request here, and if we look at the request and the response that took place, we'll see here that there's a fair bit of data that has passed back and forth between the servers. So the request contained, as we can see, 796 bytes. Notice here that view state and event validation information all pass back and forth, or in this case, pass to the server. Here is the response. Note here that we've got some information about what's going to be updated back on the client. We have all of the HTML that is displayed inside the update panel. So here's our horizontal rules, some non-breaking space. Here is the span that is the client-side representation of label 2 along with the embedded style, and then here's the date time, and then here we have again all of the view state and all of the event validation information. So what we're seeing here, and that's right, we had 785 bytes returned from the server. So what we're seeing here is all this view state, all the event validation information passes from the client to the server. The full page lifecycle executes back on the server, and then the HTML markup for the update panel gets sent back to the client along with, again, all of the updated view state and event validation information. So there's a fair bit of data that's passing back and forth here. So now let's go look at the other method, and then we'll talk a little bit about why you might choose one versus the other. So let's have a look at the mechanism for manually doing AJAX-style page updates by calling service methods. And what we've got here is very simple user interface. It's got we have a text box. We're going to let the user enter something in a text box. Click on the button. The button click event is actually a client-side JavaScript event. So what we need to do here is we need to manually call from JavaScript code a service method back on the server, and then we need to handle all of the possible asynchronous returns. So there's this JavaScript client-side programming here. There's also additional server-side programming that's required since we need to call this simple service. We've specified that we have this service reference, which is at the endpoint, simpleservice.asmx, and then we're calling here simple service, and then this method say hello that we have to define in our web service code. So here we've defined our web service, decorating the class with the attribute script service, and then here is the logic, taking an input parameter, building the response and returning it. So there's a fair bit of extra programming that's required to use this mechanism. We have to create this separate service mechanism. We have to write client-side JavaScript code to make the call and handle the asynchronous results. So it's a fair bit of extra work. Let's run this. And I'm going to stop and restart Fiddler so we can have a fresh user interface. Right. So now let's go back here. Let's refresh the page. Right. You can see that Fiddler. We've got the full page, creation as we would expect to have, just like we had in the previous demo. There's one additional call here. Is this initial call to simple service because we need to. That happens at startup for the page. Now let's go in and execute this. Now let's go over into Fiddler and look at that call. So the first thing you'll notice is that there are only 13 bytes in the request. Notice here, here's the request, and here's the response. So nothing but the data that is needed by the request, and then nothing but the text that is the response that's necessary to be processed on the server. Now, the implication here, of course, is that our logic is responsible for knowing what the service method is going to require and sending it the appropriate data, and then programmatically dealing with the data that is sent in return. So when you're using the update panel, everything is automatic for you. You just put the update panel on the page, put some controls in the update panel. You can configure how you want that update panel's behavior to happen. So whether you want it to happen implicitly whenever an event fires that causes a page post back, or whether you want to specifically identify event triggers in your client-side code. So you do have control over how the update panel works, and we've covered that in other How Do I videos. But it all happens for you automatically, whereas using network callbacks, you really significantly decrease the amount of traffic that transpires back and forth across the server. But the penalty for that improved performance is you have to write more code, and you're responsible for creating the request element in the appropriate format that's required by the service method, and you're responsible for manually processing the data that's returned from that service method in your JavaScript code. So the return method is going to get this string of text, and then back on the server. Now in our case, just for the purposes of the demo, we haven't done anything fairly complex. We've just used it as an alert. But all we're getting back is that text. So if we're going to use this for a partial page update, we're going to have to use JavaScript code to take that result set and put it in whatever HTML or JavaScript element on our page is appropriate. So the trade-off is performance. So this isn't to say that the use of the update panel isn't appropriate in lots of different scenarios. So one of the obvious scenarios is when you're using something like a data grid, and while you can program against the client-side representation of a data grid, it's pretty complex to do that, and frankly it takes some figuring out on your own. So If what you want to do is have a data grid that's pageable, so you can page through 40 records at a time, for example, and you want the update as you move from one page of records to the next to be seamless AJAX style updates to the user, makes perfect sense to put that grid in the in an update panel. Also, when you have a whole collection of controls that are all related in some fashion, so when one is going to be updated, they're all going to be updated. Probably makes sense for all of those to be in an update panel, since a significant amount of the view state representation for the user interface changes because of the dependencies there. Really, the decision as to whether or not to use an update panel versus whether or not to use manual AJAX style programming and service method calls really depends on the problem that you're trying to solve, how much work you're willing to do for the performance trade-off, and whether that performance differentiation is really necessary. But hopefully this gives you enough information to understand the difference between what happens under the covers when you're using one mechanism versus another, and then you can apply this information to the specifics of your application to make the best possible choice.